Yes. So in previous session we talked mostly about the types and probably like how the categorization could be for an assembler. What care is to be taken by the translator rather to really work out the complete translation process and so on. So we'll move further and we'll try to see a few more details about these systems, like how exactly these systems can work all together to achieve the goal of translation. Now, when this translation process is carried out, ultimately there are few things which definitely every time are maybe addressed by the system in terms of like when an object code is generated, right? When the object code is generated, so we call that language processor as the translator, okay, or the language processor as probably the code generator. Fine. Yeah, Harshita, I will address it, but let us wait for a while. So when we do talk about that code generator, so I showed you like if I open an HTML and if I type the code or if I type the text and if I save it as a HTML file through the Word kind of editor, and if I open it with some gedit or notepad kind of editor, I do see an assembly code. I do see an HTML code written. So when you are exactly executing this, executing any of the apps, for example, I'm executing this Microsoft Teams now. So some code is definitely getting executed inside, correct? At the point of execution address, the code will be executed, but how do we know where exactly the read write control is? Or from where exactly the code is read by the system. So we always say the code would be loaded in memory or buffer and then the processing would be done. Everything would be carried out in maybe virtual manner. Okay, or even one can say hidden manner. Majority of details are not known to us at some point of time. Now, how exactly these things definitely are carried out. So for that purpose, then we need to have some kind of grasping or some kind of idea. If at all I have to write my own translator, which probably as an sample, an assembler, then how do I start? How exactly I should start my work so as to get through the development of particularly an assembler. So when we saw the code is translated, we exactly saw that the translation is one to one. One line of assembly code, you get one line of object code. Now, when we say one line of assembly code to one line of object code, what are the other aspects involved there? So we like when we talked about say for a while, let me take this. So if I write nm a dot out, so it displays me all the symbols, okay, that are part of my object code or an executable. So let me say binary file. So they are even categorized into different forms, and we saw the categorization was dependent on whether it is part of which section. So there are multiple sections available internally, okay, inside the file. Okay, whatever the object code that we get. Say for example, if I try to find out meaning of each of them, like each of the word, each of the character, like D, T, capital R, small r, and so on. So, man, so you would be getting that meaning over here. A absolute, B or B BSS, C is common, D initialized data section, G an initialized data section for small object, P dot I or dash I for P format, capital I indirect reference, capital N, and so on. If you move further, okay, there are multiple such notations added. Now this information definitely is added somewhere. So if I see this looks like a table, correct? Can you see this? Does it look like a table? So let us say this is roll number Okay, first thing is roll number. Then there is second column which says okay probably type, and third number or instead of roll number let me say an identity number. Okay, then this seems to be a category or type, and this seems to be the name. So I can think of these three columns. Now when I really write it using an utility for readelf, I do see this as well. So when I really see what exactly it is, so it says symbol table. So when the translation is done, I have to make some categorization. Now whenever I'm speaking some text right now, I'm speaking some statements. Okay. Now what you are doing there, you are trying to match each word that is available into your dictionary. What are the word that I'm speaking? So whenever you find that that word is not matching with your directory or dictionary, then you suddenly ask, sir, what exactly I mean by say X word, correct? So for you, that definition is undefined, correct? And others, you already found that information. And sometime I might be referring to something which may not be part of my language, but I'm using that as a reference, which is not exactly part of my language. My language will never have that kind of statement or that kind of word, but I can use that word because it would be translated internally. So when I say look into .symtab, now when I say look into .symtab, you already understood look into that. Then you identify .symtab, I'm using a reference. And now you might try to see like where exactly I can locate this .symtab. Then when you find that on the screen .symtab is marked or highlighted, then yes, your address resolution is done. But if I say optab, now optab may not be seen somewhere. Correct? I don't know whether optab is really a proper word or not for the system. Then how exactly I'm going to relate it? So this looks for me as an undefined one. Correct? It looks to me like something like an undefined one. So then if at all such kind of situations are to be tackled, what we as an developer or as an programmer should do so as to achieve the goal with respect to understanding or translation of the process. Now when we do go about this, we need to definitely find out what are the different components or what are the different data structures those might be used at some point of time to map or to match the majority of such cases. So let us try to understand what are the different data structures those possibly may play an important role in implementation of this kind of translator. Okay, now recall while we used the Intel manual. Why we used Intel manual, by the way? Can somebody point out that thing to me? Yes, Tushar, why we used Intel manual?
Sir, opcodes.
Okay, to find information about machine representation referred as opcodes. Okay, apart from that, apart from opcodes, what exactly we tried verifying in the table in the manual? Yes, Harshita.
Some mod bits.
Mod bits. Okay, good. Okay, go on. What exactly other things were? What were the other things that we tried finding out there from that manual? Scale index, base, SIB. We talked about mod types. We talked about instruction format. Okay, and while discussing about them, we referred always an Intel manual. So while my program is getting translated, what my system is going to refer So my system would be referring to something called as data structures. And those are the data structures which would be used by the system to really complete the translation process. Now translation process would be of the program which was taken as an input and given to the system. So what those data structures possibly could be. So let me start writing. So first data structure is opcode table. There would be one location counter, or this is a variable. Sorry. Location counter or pointer, or it could be program counter, correct? Or it in IA 32-bit terminology we call it as instruction pointer. This is a variable, one variable, like in Intel 32-bit process it is called as EIP. In 64-bit process it is called as RIP. Then we talked about general purpose registers. So they are EAX, ECX, EDX, EBX, ESP, EBP, ESI, comma EDI. Then we saw special register E flags. Control execution of program. Flag register to control execution of program. Further, we saw, or we would be using another data structure called symbol table to hold the names of labels, variables, function names, in general identifiers. Okay. Then we would be requiring something called as literal table. We would be requiring something called as information of directives, EQU, correct? For a while we used EQU, DB, DD, DQ. Correct. So we will require something called as error table. Correct. So like there are so many things which would be used by us. We don't know, probably, but right now we could identify from the code translation process that we carried out manually. Though we have not addressed this. So opcode table, we tried searching into manual, Intel manual. Whenever move is used along with operand types to be different, what should be the opcode taken? So think of it as a data structure. Location counter or location pointer or program counter or instruction pointer, which would be holding address of next instruction to be executed. We even saw general purpose registers which are used by the system in 8-bit, 16-bit and 32-bit mode. So if we go with 64-bit mode, again there would be registers with 64-bit pattern. There would be a special register called E flags. There would be a symbol table to hold information about labels, variables, function. In short, identifiers. Now literals. Let me show you how it works. Now let us take these three values. Okay. Now see what exactly it did. Your A was converted, and you can see that address calculation was done with B0 plus register number RB. So 0 CL was first register, so B1, B0 plus 1 B1. BL was fourth register, so B0 plus 3, because B0 B1 B2 CL B1. Okay, then DL B2, and then B3 for BL. Correct. So DL was B2 and so on. So you can see that this number got converted to something called as 61. Now what happens if I use something like this? Let us take simply ABC. We will require only 4 bytes because this is a 4 byte number, 4 byte register. You can see how your numbers, how your characters are converted. Your characters are converted to hex representation, and that hex representation is done by simply changing that character to an ASCII value, then ASCII decimal to hex number, and that's why 97 was converted to 61. Small a 97. That's why 61 is represented there. So the address computation starts with B8. Here, B8, B9, BA. Rest of this is represented for the characters that you have. So whenever you are using something as a literal, a constant value, there would be some kind of change. So same thing. This was done for, say, what you can call it as a character value. What happens if I write move AL comma 10, move PX comma 10, move PDX comma 10. So I am taking 8 bit, 16 bit and 32 bit. And now see how this 10 is organized. So 10 when written with 8 bit value, it takes a byte. When written with a word, 2 bytes, it takes 2 bytes. When written with 4 bytes, this is the 4 byte value. Correct. So that means what? What are the immediate value that you pass on? Whether it is character or probably an integer. So each one would be converted in some form. Value 10 would not be changing the actual nomenclature or the value. 10, whatever the digit or number 10 is represented, nomenclature internally would be different depending upon how exactly you are using it. So instead, if I replace that move, say by add, let me replace. Let us see the code. Now see what is the difference between the first part and second part. Can you see some difference? See the number of bytes used to represent the things. Now with this case, like here I used BX and EDX. What is changed? This 66 was added as a prefix because it was a 16-bit value. Same case was here, 16-bit value. Apart from this, even we came to know that's about 66 from that Intel manual only. Correct? Now, if I try to understand the methodology applied at the time of translation, I can see that whenever I am taking with an arithmetic instruction, for the number, it would be taking only those many bytes which are to be referred. So this 10 and this 10. For all three cases, it took only 0A to represent 10 as a parameter. But in this case, it took first time 1 byte, then 2 bytes, then 4 bytes. So methodology is changing. So how exactly you are going to do this translation? So will you always check part of contents and will you convert it? So when this 10 is coming every time, so is it converting this 10 to 0A every time? 10 to 0A 00, 10 to 0A 000000 in an Indian format, little Indian format? I may have to, but how many times I should do this? So actually I am wasting machine cycles to carry out this process. 0A here, 0A here, 0A here, 0A here. 4 places I did the same thing. Instead, I could have done it once. I could have stored it somewhere. So maybe in some cases, my literal table may help me out at some point of time, so that the translation would be pretty easily done. But again, it would be definitely dependent upon how the system would be designed. What exactly the parameters you have taken care of while rather implementing this system. And it would be necessary to be known whenever we are trying to translate the system, whenever we are trying to translate the code internally. Because it would be helpful for us to gain idea of what exactly the conversion process used internally to represent the data. So that's why when I said literal table, there will be some mechanism which will be used. So though directly probably what you can call it as, the assemblers may not be taking into consideration these literal tables, but for every immediate value that you add. Now here, what are the translation we saw? It was with respect to your text section. What happened if you are including that into data section? Let us see this translation. Now it applied similar kind of process, the way that it was doing here. But now see the mechanism. For every character, it took 1 byte, 1 byte, 1 byte, 1 byte, 1 byte, and so on. Somehow, this needs to be tackled by us and verify whether on which section we are working currently now. If it is a text section, then do carry out this process. If it is a data section, then do carry out the process like this. If it is a code section, do the process like this. We need to always monitor this part from the system perspective, so that we should not really face any certain issue while translating the code. Because we don't know what kind of problems would be facing at later stage whenever we are implementing this translation. But it's not only about designing these tables. we definitely will require something important called as table search techniques. Now, how will you search into the table? Like the way that I showed you, maybe for example, this one, the sim tab, okay, as well as I showed you NM. How will you find, how will you search into that table? Even like we were using index while referring to an Intel manual. I used to click on the particular character and then I used to get that instructions, those instructions which are starting with that character. Say M, then I used to go to M, then I used to search MO, then I used to search for MOV. Correct? Or same thing was for add as well. So what kind of treatment should be given at that point of time? So furthermore, suppose FLD keyword of DDE. So I'm using a float thing. Okay, a float instruction. Let us see the conversion. See how this number is written. DDE DQ 10.2. Now how will you know how what kind of translation is carried out here? So let me take 1.0 as well, so that I would be able to devise some proper mechanism there. Now see how exactly 1.0 is written. F03F. So now remember, like how you represent a binary representation for a float value. You must have been taught that. Try to find out that part too. How exactly that representation is done. Correct. And whenever I tried using this FLD, it took DDE, then it seems the address is taken here. And this instruction is DD05. I don't know whether it is DD is the code or 05 is the code right now, because I am not verifying my Intel manual to achieve this goal. But whenever I do really work with and generating an as code which would be ready for debugging. So these are floating point registers. ST0, ST1, ST2, ST3, ST4, ST5. So it is a stack actually of float values. You can see that it added 10.19. Now let me add some things in the code. Now see how the values are shifting. Now before a while I was saying that it is a float point stack. Let us see. So I will write first ST7, 6, 5, 4, 3, 2, 1, 0. Breakpoint main run. Now see, it is like a stack now currently. Fine. I am saying ni first value. Now see where exactly the value is going. Where it is added? In which register it is added?
ST0.
ST0. Let me fire next. FLDZ. What happened there? Value got shifted. Correct? ST0 value was shifted to ST1 and now ST0 is having 0. FLD 0. Load 0. Float 0 to be loaded in the ST0 value. So ST0 is the top of the stack. Now we are writing FLD1 next instruction. So ST0 was shifted to ST1, ST1 was shifted to ST2. Now ST0 is having value 1 because FLD1. Now next value I have FLD pi. Pi value would be with ST0. Earlier ST0 would be shifted to ST1. Earlier ST1 would be shifted to ST2. And earlier ST2 would be shifted to ST3. Let us check. Am I right? Now, while using these instructions, I would not be permitted to directly make use of probably these registers. What I saw as a general purpose registers, they were not useful. So if I say again FLD keyword, so now ST0 will be containing 10.199 whatever. ST1 would be containing 3.14. ST2 would be containing 1, ST3 would be containing 0, and ST4 would be again 10.1119. Right? Let us see. Same thing would be there. Now you may say all 8 registers are used. What happens there next? So we don't have any instruction to do carry out these activities. So we are not sure what exactly is happening at that point of time. Correct? So let us go back and really add again this cycle. Set up again 4 instructions which are doing that loading part. ASM, GCC, GDB. Again I am displaying the values. ST7, ST6, ST5, ST4, ST3, ST2, ST1 and ST0. Run. Sorry, I have to set the breakpoint. Run. NI. Now you will see first cycle, now second cycle. Again we are having FLD. Now what should happen? We got an error, not a number, because you already have your stack full for the values. So sometimes you would be seen or you would be shown at runtime NAN kind of error. Very few times we do see that in C language code, but in assembly majority number of times you will see this error while you are working with float point values. The reason behind, like you cannot go beyond 7. 7 I mean to say total 8 registers used as a cycle. But cycle ultimately doesn't mean that it can be used. So how can I use those registers then to sort out this issue? Okay, so that I should not get an error. Somebody unmuted. Any question, please? So in the way that I used load FLD, I'm using store FST. So I'm declaring BSS F rescue 1. Fine, let us see the change. Run. Now see the values. FLD, FLDZ, FLD1, FLD5. Second cycle. Now I'm popping. Now see what value gets popped. Okay, that means that value should be deleted. What happened? Can somebody tell me what happened? See the values above and see the values below, and let me know what change you could see there.
Rotate.
Hmm? Can you speak bit louder? I'm not able to hear.
Sir, rotate.
Some kind of rotation factor is used. Am I right?
Yes, sir.
Right. So it is like a cycle. So let us do one more time. Let us do one more time. So if we go on by doing this, when we said FLD pi, now this 3.14 is shifted here because of FSTP. Now when I say FLD pi, this would be shifted to ST1 again. FLDZ ST0, FLD1 ST0. Now my program is done. So this would be, there would be kind of rotation that is happening internally at that point of time. Okay, rotation of the values. And see now how, like those who might have used say earlier systems while you were children's I mean to say in school days rather, if you had a Pentium machine, you might have heard that there is a co-numeric processor called as 8087. Earlier, till the Pentium, there was definitely a different processor used to be there for floating point operations. Now it is integrated with your Intel processor only. When this new architecture of multiple cores came into picture, it is on one board, on a single motherboard, single processor with multiple cores. And it was it was doing huge number of computations, no matter what exactly it is trying to show to us. Now you might be seeing on screen of your laptop or maybe mobile or a desktop, this screen is shown, my screen is shared. Now it is not flickering, but it is refreshing every part of second. We are not realizing that because it is very fast. And as it is very fast, it is very difficult for an human eye to really see what is happening, how many time refresh is going on, so that the things could be carried out and would be made easily visible to the user. Correct. So when we talk about all such different types, we definitely need to address how these numbers would be represented. And that's the reason why this little Indian or big Indian came into picture. It dependly is ownership of deciding how the number should be represented. The deciding policy by the processor designer. Why they did so? probably maybe a questionable criteria. But until unless we know what is the reason, we cannot really comment on why instead of this they could have used that. No, we cannot comment on. We don't have any say proper there to talk about the same. And it would be difficult every time to really find out why it is so. Because there should be some definite thinking behind why it is required to be like that. So I'm adding a link for you peoples. I don't want you to go into detail, but at least have a thorough reading of that particular text added over there. You can see in chat window, I added one link. This is from Intel's portal only. So where they are talking about understanding the big Indian and little Indian modes. What were the parameters to be addressed and so on. So maybe chapter 2 would be really important. Even chapter 3, 4, 5, like I should say all chapters rather instead. But whenever you are having free time, my suggestion would be go through it. Why do you really require them? Correct. So like when we are talking about such all aspects to be followed by the system, why exactly that byte ordering needs to be changed? I want you to work out and find out what kind of impact this is exactly making. So for to create an effectiveness in the programming style. So you can use the second type as well, a second link as well, which I added there right now. Now it talks about ARM processor and Intel processor for a while. Correct. Which is helping rather the system to really grasp an idea of why it is so. Now even like if at all we require to find out what are the different architectures and how exactly it is decided. Correct. I am also adding one more link rather for your reference, which also can be helpful. Read all these so that you would be able to gain an idea why it is so. Okay. So in next session, we'll be talking majorly about these things. So by that time, I want you to really think of how I can implement these tables as a data structure perspective. Like I think you are having a course called data structure in your current semester. Correct? Try to find out if at all we have to represent these. How do you represent this? Which one of them, whichever is seen to you, seen by you right now. Okay, so I'm adding these things into chat window again, so that it would be easy for you to really grasp an idea of what exactly I'm supposed to do. Fine, work with it and let me know like if you find any difficulty. Okay, so let me address now the point raised by Harshita. Yeah, Harshita,